So the data set which I'm using for this script is dataset_1, and here is my target column. So as you can see, like for the malwares, it's 1, and for the banningware, it's 0. Oh, yeah, here it is. So let's jump to the script. So first I've imported all the libraries, necessary libraries, which I need for this whole task all at once. So it eases the task for me. So I don't need to import it again and again. So you can see like I've imported pandas, numpy, graphviz, matplotlib, and sklearn. So our first task was to split the data. So for splitting the data, first I'm reading the file dataset_1 with the command read_csv. Then after I'm putting that into a variable, and I have given array equals to dataset.values, and the other variable is y. So what I'm doing here is that I'm reading the columns after 3 from after target, which is, as you can say, like 0, 1, 2, 0, 1, 2, and 3. So from 3, after 3, we are reading all the features from it and comparing it to the targets column. So after doing this, here are the 4 variables needed for the splitting, which is xtrain, xtest, ytrain, ytest. And the test size I've given is 0.33. So automatically the train size becomes 0.67 because the formula is test equals to 1 minus train, or like you just need to minus the test size from 1. So it will be 0.67. So after that, I'm using a classifier here. I don't need this, but I've just added. So let's run this and see what output we get. And here I'm creating all the the data set. For the X train, it's the data, the label. Oh, why it's not running? Okay. So here we can see like the data is splitted. The training set data is this, that label and the data, and we can see like it's independent variables, dependent variables, because I've given that name over here. And the test data is this, which is in metrics. So let's jump to the script 2. So in this script, I've added the variance. Rest all script is same, and this print thing. Here I'm printing all the banningwares and malware sample. Like it will show 30 and 70% because we have split it in that way. You can see like I've added the. I'm using the same file. I'm grouping it by the command dataset.groupby, and I'm using the columns target. So it will read the banningware and malware samples. And here I'm multiplying by 100 because like it will be in the point value like 0.7 and 0.3. So after I multiply, it will be 70 and 30. And here I'm adding the k equals to variance threshold. So this is the basic threshold formula. And here I'm fitting the estimator to data and calling it by the command get support. So what it will do is that it will return the Boolean mask with the true values for columns which are not dropped. After that, I'm printing the J value, which is the variance threshold one. And it's the same data as we saw in the script 1. So let's run this, and here is the accuracy. Let's see the output. So as I told, like it will be 70 and 30% banningware and malware. And okay, so here it's the because of our variance threshold which we gave, the columns will change, the rows will stay same. The columns are the features. So let's try 0.80 and see how many columns we have. Let's write down 19 over here just for our sake. Okay, let's run it. So we can see like it's outputting 15 columns, which means 15 features are displayed when we give variance equals to 0.80 over here. Let's try one more 90 and then we can move to the other script. The decision tree, we don't need it right now. So we can see we are getting 30 columns when we give 90. So it has more features if we increase the threshold. Now the third script which I have is for the random classifier. So the script is almost same as before, but the only thing we have changed is this classifier thing, and I have added the random forest classifier. So random forest classifier estimates the number of decision tree on various subsamples of data set, and it uses averaging to improve the predictive accuracy of the model. And here I'm printing the accuracy and performance. And we are using the x underscore train and y underscore train only for here, and then we are comparing it to the y predictor. And the number of trees I have given is 20 in the forest. We can change this also if we want. And it's the same over here, like we are reading all the features. So I've written the 3. So after target, it will read it and it will compare to the target. So let's run this one also. Actually, this is the confusion matrix, which we'll see in the next script. And this is the classification report. Of what we need over here is the accuracy and the random forest classifier thing, which shows the actual value and the predicted one. So we can see like there is some 0, 0 for the both and 0, 1. So this is how we do random classifier and the machine learning. So next script is for the classification report, confusion matrix, and then the accuracy. Here also I'm using the random forest classifier only, but the thing which I'm adding is that I'm doing the plotting thing over here for the decision tree. And here I'm giving the entropy. If we don't give any criterion over here, then automatically it takes Gini. So the difference between Gini and entropy is that the only difference is for the computation thing, like the range for the entropy, the range is 0 to 1, and for Gini, it's from 0 to 0.5. So after 0.5, it again start decreasing. The graph is actually like, sure. Okay, so this is the one. Then for Gini, the graph will be like this. This is 0.5 over here. So from here, it start decreasing. And for the entropy, it will be like this thing. Oh, I messed it up. So here one. So from after 1, it start decreasing. So for Gini, only the difference is the computation thing, like how they calculate and the range. So for the impurity, I guess Gini is way more better than entropy. And I have given the depth equals to 5. So it will only show like the nodes will be only 5 over there. So let's run the script and see what it output. Is it running or what? Oh yeah. Okay, so here we can see the depth is 5. 1, 2, 3, 4, and 5. Because of the depth we give, like it makes it easier if we give the depth. If we don't give the depth, then it will show the whole tree and it will be hard to learn the data. So here we can see the confusion matrix. Uh, okay, I need to close the decision tree, then only we will be able to see. Okay, so here is the confusion matrix over here, which is the this first value is the true positive, the second is false positive, this is the false negative, and this is true negative. So precision and what's important over here is the precision and recall. So recall basically is the true positives divided by true positive plus false positive, and precision is true positive divided by false positive plus true positive. Yeah, and this is the accuracy 0.91. Like if we change the variance over here, then the accuracy will also change because of the features over it. So if we don't give the any depth, and let's comment this out and see what happens. Like it will show the whole tree, which makes it harder to learn the data. So as you can see, the decision tree is way more big, and it's like it's very complex to read from here and learn the data. So it's better to give the max depth, which makes it easier for learner to easily classify and divide and normalize the data, whatever you want. So this is all I have, all 4 script for this lab 3.